thank you all for coming to the first of our lunchtime talks in science and math. I think it's our 11th year or something like that. Tony can probably correct me. We do have, what's it, 12? Okay, 12 years, which is good. The schedules are posted in a variety of places, certainly outside all the classrooms in this building, some other places around campus. So please share those and bring other folks. We do have pizza every time. Our next talk, normally we have these about every other week. So our next talk is actually this coming week. It is Lyle Carbett, who is going to be talking a little bit about paleontology. He's a bit of a dinosaur aficionado and did some work this summer, and so he's going to be talking about a dig that we had there. So I'd encourage you to come for that one. But for the future talks, either watch your email or check the schedules posted around campus.
Is Lyle's talk on Wednesday?
Lyle's talk is on Wednesday of next week, yes. So with that, it's my pleasure to introduce Dr. Tim Armstrong from the biology program.
Thanks for coming. I'm going to be talking today about some summer research I did this past summer up on the Baca National Wildlife Refuge. And there are nearly the entire refuge staff here, so thank you all for coming, which is great. Many of these folks helped me very intimately complete all of this research on the Baca this summer. So a little bit of background first. The Baca is an intriguing piece of land. It's shown here. This was a land that was granted as one of the Mexican or Spanish land grants back in 1860 when the valley was still all Spanish territory. And so when that land was granted, it's been private for most of its history, and so there's a tremendous public interest in this piece of land because the public has really been excluded from it for really since this country was settled. The Baca was a working cattle ranch for, I guess, a century, a little over a century, and they were renowned for their heifers at some point. I don't know exactly all the history of that, but one of the things about the Baca, you can see in this picture of them haying, the Baca is a huge place and it has enormous wet meadows, and that's where a lot of this hay was cut. And that will kind of play a part in the research that I was doing. So back, for those of you who've been in the valley for a little while, right around 2000, there was kind of there was another water export scheme that developed, and there was kind of a groundswell of public interest in protecting the land to stop this water export to the Front Range. And as part of that, the Baca National Wildlife Refuge was established in 2003, and then the park, what was the Great Sand Dunes National Monument at the time, was then expanded to become the Great Sand Dunes National Park and Preserve. And that was really all to protect this land and then to stop this water export. You can see the Baca here. It's an enormous place, 79,000 acres. So it runs from just north of the Menau Ranch all the way up to Lane 6 on the way into Crestone. Ron, how long is that, 20-some miles?
It's probably about 15, 16.
Okay, so 15 or 16 miles north to south. These are just some landscapes on the Baca. Can you guys see that all right, or should I turn those lights down? Try them down, but then you guys will all be falling asleep. You'll have your
No, we'll be riveted.
tummy, yeah, tummy's full of pizza and the lights down is always a lethal combination. Much of the Baca is upland areas. I would argue some of the healthiest, what we call Chico here in the valley, because it's actually got a fair amount of water. But these are some of the wet meadows, and this is really where we focused for this research. But it is just an astonishing landscape if you get a chance to get out there. The Sangres to the east. Along with the Baca, there are a lot of elk. Herds that range in the winter up somewhere in the thousands. I think Ron, you've seen herds that you would estimate up into 3,000.
Yeah.
So big herds of elk. And the elk spend a lot of time on the refuge. They do move on and off of it, but they spend a lot of time there, and they browse it, and they also graze the willows. And this grazing has been a concern to the refuge staff, and so they've set up a series of these fenced exclosures. You can see some of the older ones, these are some of the older ones here, always along riparian areas, because their concern was that there's so many elk that the willows never get a chance to grow. The minute a willow, gets up kind of and visible, the elk are on it and they are browsing. They're not actually grazing. Grazing is when you eat grass, browsing is when you eat other stuff. So they're really browsing willows. But the refuge set up 14 of these exclosures over the course of years to try and get a handle on how bad is this browsing, and is it in fact causing the declines in the willows that they see on the refuge. So 4 of them in 2006, the oldest ones, they were quite small, about an acre in size. Then 8 of them in 2011 were established. They were bigger, but then in 2012, this one here, this is just a hot wire, and they're a lot less expensive to build because they're not, they're just less expensive to produce. And they're big. They're, what, a half a mile square? They're very large exclosures. So what I did, we had been trapping up on the Baca for a couple of years, bless you, and we were trying to get a handle on the small mammal communities, just what was there, what wasn't, because we don't know a lot about this land. And so the question, this research question, was really driven by these questions about willow regeneration, and then was this browsing by the elk being felt up through the trophic levels? Here you can see what happens when you fence the elk out. This was the most dramatic willow regeneration of any of the exclosures that we worked in over the summer. But you can see the willows are responding very well to the lack of elk. So this was our question. Was this affecting the small mammal community? We had these exclosures already set up. It's just a great natural experiment where you can just test. You can trap inside and outside. And so that's what I spent much of the early part of the summer doing. Here are the exclosures. This is the northern half of the Baca. So Crestone Creek, this is Lane 6 North right here. To get your bearings, Crestone would lie right here. So these are the 2 big hot wire exclosures, and then there's one there that's kind of hidden by my red circle, but there are 1, 2, 3, 4, 5, 6 there, 2 on Willow Creek, 2 on Spanish Creek, and then you can see all the yellow are the exclosures. And then the ones that are circled are the ones where we trapped. My original idea was we would stratify our samples by creek. So we would trap 1 exclosure here, 1 here, 1. So we sampled all of the different creeks. And then we would also stratify by the year of the exclosure as well. That didn't go quite as planned. And as you can see, we ended up trapping 3 exclosures up on Crestone Creek, and I'll explain why that happened a little bit later. Please, if you guys have questions as I go, please go ahead and ask, or we can wait till the end, either one. So this is how we ran these. With Karina's help with the GIS, this was the exclosure, the map of the exclosure. So we would pick random points in the exclosure, and then she would box out a corresponding area upstream and then downstream of the exclosure, and then again you can see these random points. And then I would go out with my set of random points and I would kind of pick the ones where that match the habitat most closely inside and outside. We were trying very hard to control for all of these variables. And this is just one example. We did this with every exclosure that we trapped. We then set up these webs, these trapping webs, these were live traps. I'll show you a picture of one in just a second. So they had 10 lines, 14 traps per line. The traps were set in this radial spoke pattern, 3 meters apart, covered a little bit over an acre, about 1.4 acres. And here you can see one of those radial spokes. This was a place where we had captured something in each of these traps, and then we would flag them, so we would then put the traps back in the same exact location. Part of the reason we used this was so we could estimate density, actual density, how many rodents or mammals were in, per unit area. I have still been unable to get that to work, unfortunately. The calculations, Robert Astalos is helping me with these Fourier transforms, and oh my gosh, when you got to go ask the physicist for help, then you're in real trouble. So I haven't been able to get that part to work yet, but I am still working on it with Robert. We had a great group of interns up at the Baca and then at the Monte Vista Refuge, and they helped periodically. The Baca interns helped me set these grids every week. You can imagine we were setting 2 of these, so we're talking about upwards of 280 traps, and so it's very, very labor intensive. You can also see that the mosquitoes, we had to wear head nets. The Baca is notorious for its mosquitoes, and this was a very wet year, and the mosquitoes were plentiful, shall we say. So here you can see the little traps, and we had them all labeled so we know where they went, and that way we would capture these rodents. We baited the traps with a mixture of just oatmeal and peanut butter, a dry mix, and then we put some cotton balls in there because nighttime temperatures when we started were down in the 30s, and so the rodents, you imagine something that's used to being underground overnight in a little metal can above ground, and they suffer pretty high mortality if you don't provide them some insulation. And so in the morning, when we'd catch something, they'd make a little nest with the cotton balls, and then we would shake them out and then replace those whenever we caught something. Here you can see this is the radial spoke. We would set a meter line and then place those traps every 3 meters. When we caught something, the traps would be snapped, so you could tell there was something in the trap, and we would shake whatever it was into just a quart Ziploc bag, or a gallon Ziploc bag. And then you can look at the animals and see what you've got. And then we would ear tag them as long as most species we would put a small metal ear tag. And we just clip it, they're numbered tags, so when we recapture these animals, we could tell exactly what animal it was, where it was captured, and we could keep records that way. You can do this with one person, but it's tricky because you've got to get this animal out of the bag without them escaping, and hold them, and then get the tag and the pliers just right, and so it really worked better with 2 people. And these guys, this is Taylor Mullins. You may recognize Taylor, one of our students, and then a pathway student for U.S. Fish and Wildlife. So here's what we caught. We trapped each of these exclosures inside and outside for 3 nights, this marked recapture. We trapped over 40,000 trap hours. That's 1 trap out for 1 hour over the course of the summer. And our trapping efficiencies were just extraordinarily high. normally, if you go out and trap like this, if you catch 10%, if you catch something in 10% of your traps, that's usually pretty good. There were places where we were catching 60% of our traps had, and this one was in one spot where this was just thick with voles. I've never seen densities of voles quite like this before, but imagine having 100 traps out and having something in 60 of them each morning. The other thing you'll notice is that the trapping efficiencies improved over time. So our averages were about 14% of the traps on the first day, second day upwards about 26, and then almost 30%. Skewed certainly by these very, very high capture efficiencies in that one place. So why do you think they went up?
Word spread about the free food.
Word spread about, I think that's exactly it. Word spread about the free food. That, hey man, there's peanut butter out here and oatmeal. So, and of course, we were recapturing, and these are actually, these were total captures, so this would include recaptures. And some animals are known to get what they call trap happy, even though, you know, spending the night in one of these little metal tin cans and then having me handle you and clip something in your ear and harass you may not be the greatest. These animals, you know, they're just in those traps every time. You just catch them over and over and over again. So it was, but, you know, the good news was we caught just tons of rodents, which is always great to have lots of data, right? So I took a lot of little selfies with the rodents. This was out at the end of my hand, trying to stretch my arm. You can see the little ear tags. This was the most abundant animal we caught, not surprisingly, deer mice. These are the hantavirus carriers. So we took lots of precautions to avoid any transmission of hantavirus. 224 of them over the course of the summer. They're a habitat generalist, they're just kind of everywhere. We caught them everywhere we trapped. These meadow voles are great big rodents. Some of them their bodies are that long. They're just massive. And these guys actually, when they bite you, you know it. They'll actually even go through a glove sometimes. And, I mean, they're not cutting through the glove, but when they bite you, you know it for sure. Nearly 150 voles. The little kangaroo rats, arguably one of the cuter of the rodents we caught. 20 of them, mostly in the upland areas where it was a little bit sandier, a little bit drier. And these guys were my favorite. These were these little dwarf shrews. These things their bodies are this big. This is the smallest mammal in Colorado. And they hadn't been documented on the refuge before, so this was a new species. Unfortunately, we caught 17 of them. Unfortunately, these things have to eat like every hour to stay alive. And so if we caught them in the morning, they were still alive. If we caught them at night, they were not. Every one of them, we had extraordinarily high mortality among these shrews just because they don't have the body mass, you know, to get through the night without just eating constantly, kind of like a teenage boy. and they're just ferocious. They're this big, and when you catch them, they would just sit and just chew on your glove and bite you so that you would let them go. We caught 10 least chipmunks, bigger. You can see that one's ear tagged again.
Were you able to ear tag those shrews?
No. No, my gosh. No, what we did when we had things that were too small to ear tag, we used colored markers on their bellies, and then we would turn them loose. Yeah. There's one other thing I'll show you that we couldn't ear tag for another reason, but these guys are interesting. This is a northern grasshopper mouse. You probably never heard of them. They are the carnivores of the rodent world. These things are like wolves. They don't really howl at the moon. They squeak at the moon. And they eat mostly invertebrates. They eat a lot of insects, but they also will kill and eat other mice. Not a lot of them, 5 of them. They're interesting. You can smell them when you catch them. They have a real strong nitrogen smell because they eat a lot of meat and a lot of insects. So you can actually smell them when you catch them in the trap. Their tails, their tails are pretty bare. That's how you can tell them from a deer mouse. Their tails aren't furred. They're not very furry. These guys, a couple of these 13-line ground squirrels, we couldn't ear tag them either because their ears are so little that we couldn't get the tag them. So we would color them, even though they're big. I mean, these are this long. But we only caught 2 of these. They're not real common, well, at least in the areas where we were trapping, they're not real common. And then 1 northern pocket gopher. This is an animal, they rarely come above ground. They're really strong burrowers. You can see how big their feet are. Their feet are just massive, and they're burrowers. The farmers and ranchers don't like these things because they eat the roots of their crops. So they get underground. You see them in the spring up high, where when the snow starts to melt, there's all these places where the earth's all overturned like that. That's these guys. But we caught just 1 of those, and this species I don't believe had been documented on the Baca either. So we were able to at least document a new species on the refuge. So now what I'm going to show you is the comparisons. So in each slide, inside the exclosure, outside the exclosure, the total number of individuals captured, not recaptures, not including recaptures, and then species diversity indices for each one. So the Crestone Creek, this was a 2006 exclosure. Very comparable, although you can see comparable both in composition and number captured. The species diversity is lower here because species diversity is a complicated measure. It's both the number of species and relative evenness as well. So if you've got 1 dominant species, then your species diversity index will be a little bit lower. And you see that reflected down here. This is a little bit lower because we had just more deer mice in that inside the exclosure. Crestone Creek, this was a hot wire, one of the big exclosures. Much more species diversity, much higher here. Again, the outside, very, very simple, mostly deer mice, a few voles down in the Baltic rush. We captured more individuals here, and we had a much higher species diversity than outside. The West Hotwire exclosure, again, one of the big ones. Inside, we caught a lot more, but again, because of all of these individual species, our species diversity estimates ended up being higher on the outside. You see, one thing you'll notice, voles and deer mice in virtually every place we trapped. Spanish Creek, this was Vole Haven. This is where I had that 60% capture efficiency. We caught 50 voles in 3 days. I think they were, in fact, this is the only place we caught 2 voles in the same trap. And I don't even know how the hell you can do that. Because you'd have to say, like, okay, let's both go in right now. Because once one goes in, they usually trigger the trap. And that happened twice here, and I had never seen that. So you shake one out, and you think you're done, and then whoop, here comes the other vole. It's like, what are you guys doing in there together? So very strange, but just enormous numbers of individuals. Again, here, species diversity almost equal. Cottonwood Creek. Here, lots more outside, but much higher species diversity outside. We caught all kinds of things at that Cottonwood Creek exclosure. A lot of dwarf shrews. This was the place where we caught the most shrews. And even some kind of up, we're normally in this wet Baltic rush, but sometimes in dry Baltic rush, but here, some of them we were even kind of right along the edge of that, where that transitioned into that upland area. But the shrews were pretty exclusively Baltic rush, as were the meadow voles, although again, they would transition into those drier areas. This northern grasshopper mouse was interesting because this was the same mouse. We caught it inside the first night, and I let it go. We marked it and let it go. The next day, the thing had to be 100 meters away outside the exclosure in another trap. So again, because these things are carnivores, they're ranging much more widely than once they're eating seeds and plant material and stuff like that. Dead Man Creek, again, lots more individuals inside and much, much higher species diversity. And this was the hardest one to understand because the habitat here was just a perfect match. I mean, inside, outside. But there were striking differences between the inside and the outside. And this is a fairly recent exclosure. It's one of the 2011 exclosures. One of the interns helped me work on this GIS map. He built, this is the grid, okay, so these are traps 3 meters apart. And what we wanted to do was just experiment with adding layers with GIS, which is something pretty neat you can do. So we would do first night, what did we catch and where? Second night, what did we catch and where? And then third night, what did we catch and where? And really what this thing, and I have to tell you, Jared Beaton helped me with this, but the projections for the grid are slightly different than the projections for the background map. And so this thing actually should be located right up here where it was not, this is the creek right here. We weren't trapping in the creek. We were trapping in this upland area here. So that's slightly off, but I mean, it's a matter of 20 or 30 meters separation. But the thing that was interesting here, we don't see it. You see deer mice all over, kind of like what we talked about earlier. We see the least chipmunks kind of centered, although there's one way out here in these drier areas. Northern grasshopper mice, 2 of them, and then the kangaroo rats, again, were kind of scattered. But in some of the other exclosures, these maps show these very, very fine detailed differences in habitat. So you can see where you caught the voles, that's the Baltic rush. Where you caught the deer mice, that was the upland habitat. And I haven't done these for all of the exclosures yet, but it's one of my longer term projects. I don't know GIS well enough to do this on my own, so I have to have help with it. So I'm at a bit of a disadvantage there. But they were really very interesting. You could just see the differences in these very minor differences in habitat. So the mean species diversity did not differ significantly inside and outside the exclosures. You can see that the mean was a little bit higher inside, but because we only ended up with 6 exclosures, because one exclosure took a week to trap, I worked on this project for 6 weeks. We only have paired t-tests with 6 and n of 6. The species trapped inside and outside the exclosures didn't differ, but the species captured stratified by exclosure did vary, and you can see that in those pie charts I showed you before. The interaction term was not significant, so it didn't matter. The species didn't differ consistently among the exclosures, and again, that's probably because of the deer mice, which were kind of everywhere. The other thing I was very interested in was trying to see if the age of the exclosure made a difference. One might argue that these older exclosures as a vegetation, because it's not being browsed by elk, that as it grew up and then became kind of what they call rank vegetation, where it's old and there isn't a lot of new growth, that might affect the rodent and small mammal communities. You can see the regression here is very, very strong, but there's a major problem, actually several. One is we only tracked one 2006 exposure, and this one was special, and I'll show you why in just a sec. If you just look up here, there's really no pattern whatsoever. So we need more data from these 06 exposures to actually test this particular hypothesis. And again, this is strictly just species diversity. So how many were there, how many species, that kind of combination of things. So this is the 06 exposure. Last spring was an extraordinarily wet year on Baca, and this exposure was flooded. We trapped it first, and we probably, well, if we hadn't trapped it first, we wouldn't have trapped it at all, because we set traps the first night, creek came up. We gathered our traps that were underwater, the ones that hadn't been carried away by the creek, and we put them up just on high ground. So our grid, our theoretical grid, kept shrinking and shrinking until we had like one line on this little dike you walked along, and then a few other traps here and there. So these data are, the data from that 06 exposure are virtually worthless, really, because we ended up, I think, with only about 50 traps out at the end instead of the 140 that we wanted. And so that was just kind of a disaster all around. But it was also just part of working in the field in a high water year. The outside the exposure was also flooded, but we were able to work around the flooding a little bit better there. So these data, that's why sorry. I have absolutely no confidence in this data point right there. So that would be something that I'd like to go back and trap more of these 06 exposures. The other thing you'll notice is we trapped, other than Crestone Creek, and the exposure I was just talking about was one of these right here when the flooding was so bad. These bigger ones, they were half mile square. The creek went through them, but you could avoid the creek there because they were a little bit bigger. We ended up trapping, here are the dates. So here's the 06, here's the 12, and then all the rest of these ended up being 2011 exposures, because this was the only place we could get to. The roads were underwater, there were ducks feeding on the roads where we were driving in the morning. I mean, literally, there were ducks using the roads. It was just crazy wet. And we tried to get to these, you're coming downstream, and this is all these wet meadows I was telling you about, all of that darker color. And so in these wet meadows here, there was just simply too much water. And then as they began to dry, I wanted to trap, there's 06 exposure here, wanted to trap that one really badly, but by the time it dried out, if you only have a week where the thing was underwater, your rodent community isn't going to be a good reflection of the normal rodent or small mammal community, because everything's been forced out by the flood. That they go to high land just like we would in a flood. So we ended up trapping all of these up near the headwaters, and although the data are of interest, we didn't really, I just simply wasn't able to stratify by the year of the exposures were established. So that would be, again, continuation, something I'd like to go back and do in a different year, but then you've got problems that you can't control moisture levels from year to year, and all that affects your rodent community as well. So that was just kind of one of those things working in the field. So the question, is this browsing and grazing affecting the small mammal community? The answer is maybe, but yeah, after all of this work. I think if you trapped all 14 Xclosures, that would be long. If we trapped all 14 Xclosures in 1 year and there hadn't been flooding that we had, it's possible that there's an effect. But if you go back, if you remember those pie charts, some of them were greater inside, some of them were greater outside, some of them were almost identical. So I'm not real sure there's a pattern, so I don't know. And the rodents can move through these Xclosures freely, right? I mean, they're meant to fence elk out, but if you're a mouse, you can just go in and out of these things. But what we were really trying to get a feel for is, are these differences in vegetation affecting the mammals? My guess is it probably having a bigger effect on birds, because many of these birds like to nest in willows, but didn't seem to have a huge effect on the mammals. I'd like to thank U.S. Fish and Wildlife for a summer faculty fellowship program that is just in its second year, where Fish and Wildlife is inviting faculty from minority serving institutions like Adams State to come out and work on the refuges and learn more about fish and wildlife, and hopefully communicate their mission and job opportunities to their students. Adams State supported this. We partnered with Colorado Parks and Wildlife. They're working, they're trying to understand the distributions of plague. There is plague, well, there was no reports of it in the valley. Plague occurs at low levels across the west here. And it is the same plague that caused the Black Plague. So all the mortality that we had, we saved for these guys. We tried to get ticks for them, or not ticks, fleas. We tried to get fleas, but we had one intern, she had a dog, and she'd spot those fleas and she'd catch them, and then she left, and I was like, oh, there goes a flea. You know, I just never could catch the little boogers. So that didn't, the flea part didn't go so well, but we did have some mortality, so they've donated their bodies to science, and Parks and Wildlife can look and see if they've got plague or not. Okay, any questions?